Okay, ladies and gentlemen, this will be a quick discussion about confidence intervals on proportions, and we'll talk about calculation and a little bit of interpretation. So here we go. The situation is this. You have a population that's too large to take a census, and you're collecting types of data that you can get either a yes-no answer or true-false answer, or maybe categorical data. So for example, maybe you are asking, do you prefer this ballot measure? Are you voting for this candidate? What's your favorite color? Should long movies be split into 2 installments? These sorts of questions. Now, when you make a sample of the population, you have no way of knowing the true population proportion, but what we want to do is we want to estimate it. So first, we're going to talk about what is a sampling distribution. Then we'll talk about the sample proportion. Then we will put together the standard error and build what's called a confidence interval. So let's look at a quick example here. So in Excel, I have this kind of worked up example. So is it good that the last book of a long series, so like Hunger Games, Harry Potter, any of those, is turned into 2 movie installments? So let's presume that over here in the left-hand columns, we have every single person's opinion, and there are almost 1,500 people in our list. So let's just presume that that's somehow, we're able to poll that. But we can't actually measure all of them. So if we take a sample of 30 people, and so I have Excel set up to actually sample 30 people and pull out their yeses or nos, I can write down the proportion of people who said yes in my small sample. So if I got 15 out of the 30, I've got 50%. Now, hypothetically, if we were able to do this over and over and over again, every time we would get a slightly different proportion. Now, when you do this over and over again, you build what's called the sampling distribution. And what you don't know is where you fall in this sampling distribution. So I'm going to take a moment and fill out the rest of this distribution so you can see it, and then we'll look at a little bit bigger example. All right, so now that I've built this sampling distribution, what I've done is I've taken 40 different samples from this population. The samples are all of the exact same size, so I've sampled 30 people 40 times and plotted the proportion of people who said yes to this question. And you'll notice that this actually follows this nice symmetric distribution. If you do this infinitely many times, this will follow a normal distribution, which is actually pretty astonishing. It's called the central limit theorem. So if we come back to here, let's say we take a sample of size 30. We find a proportion of 25% of the people saying, yes, they think these movies should be split into 2. How do we actually estimate the population parameter? Because I don't want to take repeated samples. So what we're going to do, let me pull up the other Excel document, is we're going to start building this situation in Excel. We first estimate the standard error. So the standard error is given by the square root of your estimated proportion times, that's the estimated chance of success, times 1 minus that, so that's the estimated chance of failure, over your sample size. Oops, I didn't have n there, sorry about that, over B2 or B1. And then you pick your confidence level. Now, the confidence level is how sure do you want to be about your estimation. Now, if you've got a low confidence, that's a narrow estimate. A high confidence, that's a wide estimate. So let me clarify. So we've got about 25%. So if I want to be maybe 68% confident, I've got this little narrow band that I'm going to reach between here, and here, in between those two, and say I'm pretty sure the answer is there. If I want to be more confident, my band is a little bit wider. If I want to be even more confident, my band is even wider. And to make that determination, we use some critical values from the normal distribution, which tells you how far out to go from your estimated mean in order to capture a certain percent of your information. So if my confidence interval is, say, 90%, then my critical value is 1.64 from this table. And I can build my confidence interval, which is highlighted right here, by saying, all right, I'm going to take my estimated proportion minus critical value times standard deviation. So I've got one standard deviation, or 1.64 standard deviations below, and I've gone plus 1.64 standard deviations above, and now I have a confidence interval. So in 90% of the samples of the same size taken in the same way, we're going to capture the true proportion. So we think that the true proportion is probably between about 12% and about 38%. The margin of error on that is just how much you went up and down from your center. So z star times standard error, enter. So our margin of error is plus or minus about 13%. If I wanted to make this 99%, I can change my z star value to 2.58, and if I built my Excel file correctly, I did, I've got a wider margin of error, or larger margin of error, and a wider confidence interval. So I'm 99% confident that I'm between 4 and 45%, which of course is a wider interval, but I'm also more sure about it. The interpretation is that in 99% of all samples of the same size gathered in the same way, we will capture the true proportion in our confidence interval.